the type of exercise or the mode of which you do the exercise is really critically important for any training program. So this is particularly due to the specificity of how muscle adapts. So if you're doing a specific type of exercise, specific type of muscle contractions, you'll get a specific adaptation to that particular exercise. But that generally won't translate into another type of exercise that isn't specific to what you were initially training for. And so in this short lecture, I'll give you some examples, some studies that were done looking at specificity on different modes of exercise. So exercise type of mode refers to the specificity of muscle contractions, and this results in specific adaptations to those contractions, which is the specificity of training. And you've all probably know a lot about specificity. You've probably experienced it yourself, how some types of training generally don't translate into a performance in a different activity. So here's an example of one of the first examples looking at specificity, looking at running and swimming. So they did a 10-week running training program. Now the VO2 max increased 6.3% with running, but then they did a swimming VO2 max and it only increased 2.3%. So there were improvements in cardiovascular fitness, but local peripheral improvements were much higher with the running, because that was what the exercise, the training involved, but it didn't translate into other muscular movements such as the upper body for swimming, and so the improvements were quite small, about a third that of running. So the conclusion is that you need to take into account local skeletal muscle adaptations when it comes to improvements in VO2 max, because remember, VO2 max is not just heart rate times stroke volume or cardiac output, it's multiplied by the AVO2 difference, so the extraction of oxygen at the muscle, and these are where the adaptations occur. So you extract more oxygen, you got more mitochondria in order to take up that oxygen. Here's another example of a study looking at where they had a group or three groups, and they had one group doing enhanced running, so they did extra running training, and these were already habitual runners, a lot of them. Then we had one group doing running and swimming, okay, doing roughly the same amount of time per week, and then we had a control group just doing their normal thing. Then they did a 3.2k run time trial. TT is a time trial, so they just timed them over 3.2Ks. Then these are the results. So this is the percent of pre-intervention time. So in other words, the lower the graph, the better. In other words, they were faster in their 3.2 kilometer time, and they just used 100% of their pre-time versus their post. So the enhanced running group, which is here in the black, they were looking at 3 to 4% lower, better time in their 3.2k run time trial. Whereas the cross trainers, the running and the swimming, they were about 1 or 2% faster. Okay, and then the control group, there was no real difference. They were still around 100%, maybe slightly lower, but statistically no difference. So what this says is that if you want to be good at running, then just do running. You don't add swimming to it, because it's not going to improve your running. It may make you fitter than if you did nothing at all, but it won't. If you want to be a good runner, then just run. I think I've shown you this before. These were tests I did a couple of years ago in our lab. So my history is cycling. So all I've done in my sporting career was cycle. And so my VO2 max in cycling is much higher than running, or a little bit higher than running, I should say. I rarely run, and rowing, which I've done many years ago, rowing is still lower again, and then arm cranking, which is about half my cycling VO2 max, I never do, and so the VO2 max is much lower. So these were all these tests were done to absolute maximum, so I couldn't have gone any harder, and this is what happens. So I've definitely adapted to cycling, and at the detriment to my running, rowing, and arm cranking. Now, if I went and did only arm cranking, then I might be able to lift this a bit higher, but probably not as high as my cycling or running, because I've got a much smaller muscle mass here, not really using the legs. And the heart rate really matches the VO2 max. Okay, so I couldn't get my heart rate up to max because I just the activity was not specific enough in running, rowing, or arm cranking. In the case of arm cranking, the muscle mass was too low anyway. So you can see that definitely affected my VO2 max for these tests. So it's just another example of how testing needs to be specific to the activity. So you don't test a cyclist by doing running or rowing or arm cranking, or vice versa. Here's some examples of some studies done on runners, cyclists, swimmers, triathletes, and untrained individuals, and they're looking at their running VO2 max. Okay, so their maximal oxygen uptake values for running, and they used their running VO2 max as their reference point. So running was 100%. Okay, so that's when it came to comparing cycling and swimming. And each one of these is an individual study looking at comparing running, cycling, and swimming. So quite a lot of studies over the years looking at this. So when you look at the study of runners, okay, that's their running VO2 max, 100%. Then they had the runners do a cycling VO2 max, and they're all around 90% of their running VO2 max. So generally, we usually say that for people who don't cycle, tend to be more runners, then their cycling is going to be around 10% lower than their running VO2 max. So obviously you wouldn't have runners doing a cycling VO2 max because it's going to be 10% lower. Then we have our cyclists compared to their running VO2 max, and the cyclists are all around 100%, if not higher. So they had higher VO2 max than their running, which is similar to me, because they're adapted to cycling. Then we go to swimming, and their cycling VO2 max was lower in at least 2 studies, about the same as their running. But then we look at their swimming VO2 max, and it's around 95%. Okay, 99. So the range is around 93 to 99%. So the swimmers could get close to their running VO2 max, okay, using a swimming ergometer. Whereas the triathletes are kind of a little bit in between. They couldn't. Their swimming was fair bit behind their running, and a fair bit behind their cycling, but both cycling and swimming were behind their running. Untrained individuals, same again, very similar to the triathletes. Cycling VO2 max was lower than their running, and their swimming was a lot lower than their running, about 20% lower. So you can see how specificity really has a big impact on when it comes to testing VO2 max. Here's another example of a study where they did training. So they had one group training with arm cranking, and then they had another group training with leg cycling. And then they did VO2 max tests on both leg and arm to see if there was any cross-training between the 2 specific activities. So here we have, this is all the data from the AG group or arm group, and this is the leg group here. So all this here is the data for the leg group, and all this here is the data for the arm group. And this is training pre and post. So power output, watts, VO2 max here, and so on. So if I highlight the power output at max, so that was higher for the arm cranking. So these are the arm crankers, and they saw adaptations to their arm cranking. Their VO2 max for arm cranking increased. So this little asterisk here signifies a statistical significance. Whereas here, the leg cycling, there was no statistical significance. Okay, so there was no effect of doing arm cranking with leg cycling. Then we look at the leg cyclists, and they saw increases in leg cycling, power output, and VO2 max, but there was no increase in their arm cycling. So the group that was training just the legs saw no improvement in their arms, and the group training their arms saw no improvement in legs but did with their arms. So again, this is a good example of how specific training is. So when you formulate an exercise training program, you really need to think about the mode of exercise and the mode of testing as well. Okay, so talk to the client, talk about their goals, what they want. Do they want to do their best time in the city of the surf? Well, then you're going to go with running, obviously, not cycling or boxing or swimming. So you've got to keep it specific to get the best adaptation possible.